In this past paper question, we will be focusing on resistivity. But more importantly, we will learn how to work with proportions. And that's why I've decided to start with this last part, because you will see after we have solved this question, the others will be very easy to answer. So the question is basically this. We have a wire and the diameter of this wire is given. It's 0.41 millimeters. And also this wire has some fixed length, let's say L, and this is the diameter D, and this wire has some resistance R. Now the question is that if the manufacturer wants to change the length of this wire, but at the same time we want the resistance to remain constant, right? So initially we were using some length of the wire L, but now we want to make a hair dryer using only half of this length, but at the same time we want resistance of the wire to remain constant. So the question is, what diameter wire must be used? Of course, if we are changing the length, and at the same time if we want to keep the resistance constant, the diameter has to change, right? So initially it's 0.41 millimeters, and now we are using half of the length of the wire, so the diameter must also change. The first question is, how is diameter, length, and resistance, how are these quantities related? And this is basically the definition of resistivity. So resistivity gives you the relationship between resistance, length, and area, and the equation is that resistivity equals resistance times area divided by length. In this equation, you can see this question has 2 points, so you have to mention what each symbol is representing. This first symbol, rho, is representing resistivity, R is resistance of the wire, A is cross-sectional area of the wire, and L is length of the wire. Cross-sectional area of the wire is this area right here. This is what we call cross-sectional area of the wire, and length is just length. Coming back to our question, now we have an equation which relates resistance, resistivity, area, and length. We want to rearrange this equation for resistance. So if I rearrange this for resistance, I will get R equals rho L divided by A. And also we are given diameter, not cross-sectional area, so I want to write this area in terms of diameter. So I can write it as rho L divided by pi, and because area, cross-sectional area, is given by pi r squared, but r is related to diameter, if you divide diameter by 2 you will get radius. So instead of writing r squared, I can write d divided by 2 squared. So now I have an equation which relates resistance, length of the wire, and diameter, right? I can use this equation here. So let's start. Let's say when the diameter was 0.41, let's call it the old diameter. So for this diameter and for length L, let's say the resistance was also R old. So our equation will look like this. R old is equal to rho, that is resistivity of the wire, length old divided by area old, but area, as I've already explained, it is pi d divided by 2. So I will write pi d old divided by 2 whole squared. So this is basically pi r squared. Okay, now when we change the length of the wire, the diameter will also change in such a way that the resistance remains constant. Okay, so I can write that resistance nu will be equal to rho, the new length L nu divided by pi, and diameter I will also change, so d nu divided by 2 whole square. Now the basic requirement of the question is that we want the resistance to remain constant, right? We want the old resistance and the new resistance to be exactly the same. So we know that R old must be equal to R new. That means we can set these two equations equal to each other. So that's what I will do next. I can equate these two equations. I will get rho L old divided by pi d old divided by 2 square equals rho L new divided by pi d new divided by 2 whole square. And now you can see rho is resistivity. I didn't write resistivity new and resistivity old because I will explain in a moment when we solve this first part again what is the meaning of resistivity. Right now you can just consider it a physical quantity which does not depend on length and diameter. So that's why when we change the diameter and length, resistivity does not change. So the resistivity will just cancel, and pi is also constant. Pi will also cancel from both sides. And if I take square in the denominator on both sides, I will get L old divided by d old square divided by 4 equals L new divided by d new squared divided by 4. And you can see that this 4 will also cancel from both sides. So finally we are left with a simple equation that L old divided by the old diameter squared equals L new divided by new diameter squared. And now we are given that the length is, the new length is half of the original length, right? So this part right here in the question, using half the length of nichrome wire. So that's why we know the new length in terms of the old length. So first of all, let me rearrange this equation. L old divided by L new equals d old square divided by d new square. I just moved this L here and this d old square here. So now we know that L new in terms of L old is just half, right? So L old, I can write L old divided by L new. Instead of writing L new, I can write L old, the old length, divided by 2, right? And this must be equal to the old diameter squared divided by new diameter squared. And now L old will cancel with L old, and this factor of 1/2 in the denominator, you know that this must go here on top, and we will have 2 equals old diameter squared divided by new diameter squared. And now if we want to find new diameter, we rearrange this equation for d new. So I will have d new squared equals d old squared divided by 2. And finally we want just d new, not the square of d new, so we can take square root on both sides, and we will have that the new diameter must be equal to old diameter divided by square root of 2. So this very simple equation will solve this question because the diameter is given 0.41 millimeters. You can just divide 0.41 millimeters divided by square root of 2, and that will give you the new diameter that you have to use if you want to use half the length of the wire, but still you want to get the same resistance, right? So the important part is not this final answer. The important part is this whole process, this whole question, the way we solved it, right? And I solved it in this detail because you can apply the same method to any question which is based on working with proportions. So in this question, you had to work with proportions because length and diameter were proportional to each other. So that's how you figure out what the proportion is between the two quantities and how you can solve one in terms of the other. Now, once we have solved this question, coming back to the first question, define resistivity. So resistivity, which we represent by this symbol rho, RHO, this is actually property of the material from which the wire is made, right? So if the wire is made of iron, it will have a specific resistivity. If the wire is made of copper, it will have a different resistivity. So on the other hand, resistance does not depend on the type of material of the wire, right? Resistance actually depends on area and length. For example, if I reduce the length, let's say if I'm using half of the length of the wire, the resistance of the wire will change, but the resistivity will not change, because if this wire was made of, let's say, copper, if I cut the wire in half, it is still made of copper, right? So that's why resistivity will remain constant. But if I just cut the wire in half, changing the length without changing area, cross-sectional area of the wire, so the resistance will change. In this question, the resistance didn't change because we also changed the diameter of the wire. So we changed the length, but at the same time we changed the area of the wire. That's why, and we changed them in such a way that the resistance remains constant, right? So in summary, resistivity is an intrinsic property of the material of the wire, right? So resistivity is an intrinsic property. Intrinsic mean that it has to do with the nature of the wire, what it is made of, not with the dimensions of the wire, not the length and the area of the wire. So resistivity is an intrinsic property. It doesn't depend on dimensions. On the other hand, resistance depends on dimensions. Resistance is not intrinsic. If I use a wire of different dimensions, it will have different resistance. Okay, now these other questions are very easy to solve. So this question right here says that heating the element used in a hairdryer consists of long nichrome wire coiled around an insulator. The hairdryer operates at 230 volts and has a power of 1 kilowatts. Calculate the resistance of the heating element. So we are asked to find resistance and we are given voltage and power, right? So of course we cannot use this equation which we wrote down for resistivity. We have to use an equation which includes power and voltage, which is very easy. If you remember, power is defined as IV. This is current and voltage, and using Ohm's law, which is V equals IR, if you substitute I here, I can rearrange this Ohm's law for I will be equal to V divided by R. So if I substitute this equation for I in the equation for power here, I will get for I can write V divided by R, and I have another V, and the equation for power will be V squared over R. So this is the equation that we have to use. Power equals voltage squared divided by resistance. So power is 1 kilowatts. We have to convert it into watts. So it will be 1000 watts equals voltage squared, which is 230 squared divided by resistance. So if you want to find resistance, you can change this equation. So resistance will be 230 squared divided by 1000 watts, and you should get your answer in ohms, in the units of ohms. Okay, second question. Wire has cross-sectional area of this. Resistivity is given. Calculate length of the nichrome wire. So again, we have to use our equation that resistivity equals resistance times area of the wire divided by length of the wire. And you can see we have to find the length. So we want to rearrange this equation for length. Length will be equal to resistance times area divided by resistivity. So now you just have to plug in the values and calculate. Cross-sectional area A is this quantity given right here. Resistivity is also given here, and resistance is what we just calculated in this question here. So you have to take this value of resistance and use it in the next question. Okay, one more thing, the units of resistivity, right? So this equation, from this equation you can see the units of resistivity should be the units of this all of these quantities combined. So resistance is measured in ohms and area is measured in meter squared divided by length. Length is measured in meters, so divided by meters, and you can see 1 meter will cancel and the units of resistivity will be ohms times meters, which you can see here in this question also. It is ohms meter. So if you want to define resistivity, you have to mention all of these things. You have to write an equation, you have to mention what each symbol is representing, and also you have to mention the units of resistivity.